Welcome back, Math Masters. A new scroll has arrived at the dojo gates. Today, you'll begin training to earn the Comparing and Ordering Fractions badge. For 1/2, 10/24, 8/3, and 3 3/4, record equivalent fractions using a common denominator. Order the fractions from greatest to least. Explain the following. Why is using a common denominator helpful when comparing fractions? What might happen if we try to compare the original fractions without one? Study well. The path to mastery begins now.
Math Masters, we need your help. We solved the same problem but got different answers. Check out the problem. What do you notice about the fractions we're working with? We're working with mixed numbers, and there can only be one right answer. You're right. Let's go step by step and spot the differences. That should settle this. So, we had to put 3 7/10, 2 9/10, and 3 1/10 in ascending order. First, does ascending mean least to greatest or greatest to least? Right. Ascending means least to greatest. I checked if any needed simplifying. Same here. They're already simplified. Then I checked to make sure the denominators are all the same. Yep, they are all tenths. Now comes the difference. Mia, you said 3 1/10 was smallest, but I said 2 9/10 was smallest. Math Masters, who's right? Pause here to record your thinking in your guided notes. 9/10 is greater than 1/10, but the whole numbers are the biggest part of each mixed number. 2 9/10 is less than 3 1/10 because 2 is less than 3. Oh, you only checked the fractional parts. Remember, we must check the whole numbers too. Since 2 9/10 has a whole part of 2, it's less than 3 1/10, even though 9 is greater than 1. With mixed numbers, order whole parts first. So, the smallest is 2 9/10. Between 3 1/10 and 3 7/10, the wholes match, so compare numerators. 1 is less than 7, so 3 1/10 is next. That makes 3 7/10 the greatest. Phew, glad that's sorted out. Oh, great idea, Mia. Let's try the next one together. Which is bigger, 12/9 or 7/5? What's your guess? A, 12/9, B, 7/5, or C, can't tell yet because the denominators are different. C, right! We need a common denominator to compare. When denominators match, the pieces are the same size. Then we just compare numerators to see which is bigger. Let's get down to business. First, simplify. For 12/9, what's the greatest common factor? It's 3. So divide both by 3. That's 4/3. Now for 7/5. What's the GCF? Just one. That means 7/5 is already in lowest terms. Next, we need a common denominator. We list the multiples of 3 and 5 like this, and then circle the lowest common multiple. 15. Now that we have the common denominator, we rewrite the equivalent fractions. 3 times what equals 15? 3 times 5 is 15, so multiply the numerator by 5, which results in 20/15. Pause here to rewrite 7/5 using a denominator of 15. 5 times 3 equals 15, so 7/5 is equivalent to 21/15. Now that our denominators are the same, we can compare the numerators. Which is greater, 20 or 21? 21 is bigger, so the fraction 21/15 is the largest. Good point. That doesn't answer the question, because 21/15 isn't in the original problem. To answer the question which is bigger, 12/9 or 7/5, we need to put 21/15 back in its original form. 21/15 was originally 7/5, so the final answer is 7/5 is greater than 12/9. We're almost ready for the challenge. Let's put everything together with this problem. Put these fractions in descending order. 3/10, 22/5, and 4 and 9/18. What's different here? Yes, this time our three fractions are a combination of a proper fraction, an improper fraction, and a mixed number. And it's descending order, which means going from greatest to least. Step 1, simplify. Only 4 and 9/18 can be simplified. What's the GCF of 9 and 18? 9. Divide both, so 4 and 9/18 becomes 4 and 1/2. Oh, good question. How do we compare a mixed number with the others? Convert it. Let's change 4 and 1/2 to an improper fraction. That's our new Power Up technique. Converting fractions to the same form can make it easier to compare. In fact, you can choose to convert everything to mixed numbers or everything to fractions. Just make sure they're all in the same form before you start. Now, let's convert 4 and 1/2 to an improper fraction. 2 times 4 equals 8, plus 1 equals 9. So 4 and 1/2 is 9/2 as an improper fraction. Now, we need to put 3/10, 22/5, and 9/2 in descending order. Are we ready to compare? Not yet. First, we need a common denominator, so we're working with pieces that are the same size. Here are the multiples of 10, 5, and 2. What is the lowest one they all share? The smallest multiple they all share is 10. We need to rewrite equivalent fractions with a denominator of 10. Oh, but 3/10 already has a denominator of 10, so it stays the same. Looking at 22/5, we ask ourselves, 5 times what equals 10? 2. And what's 22 times 2? 44. So the equivalent fraction is 44/10. Then, to rewrite 9/2 with a denominator of 10, we ask ourselves, 2 times what equals 10? 5. Multiply by 5 to end up with 45/10. Now we can compare. The numerators are 45, 44, and 3. Descending means greatest to least, so the order is 45 tenths, 44 tenths, and 3 tenths. Final step, switch back to the original forms. 45 tenths was the mixed number 4 and 9/18. 44 tenths came from 22 fifths. 3 tenths stayed the same. So in descending order, the answer is 4 and 9/18, 22 fifths, and 3 tenths. Your challenge still awaits. Complete it, and the Comparing and Ordering Fractions badge is yours. For 1/2, 10/24, 8/3, and 3 3/4. Record equivalent fractions using a common denominator. Order the fractions from greatest to least. Explain the following. Why is using a common denominator helpful when comparing fractions? What might happen if we tried to compare the original fractions without one? Put all your skills together and solve this in your guided notes now, Math Masters. The first step is to simplify. The only fraction that can be reduced is 10/24. The greatest common factor of 10 and 24 is 2. So when we divide both by 2, it becomes 5/12. The others are already in the lowest terms. Next comes our power-up technique, converting the mixed number. Since there are 2 improper fractions and 1 mixed number, let's convert the mixed number. 4 times 3 is 12, plus 3 is 15. We keep the denominator of 4, so the mixed number becomes 15/4. Now we need a common denominator. The denominators are 2, 12, 3, and 4. The lowest shared multiple of those is 12, making it the common denominator. So let's rewrite each fraction with 12 as the denominator. 1/2 becomes 6/12 when we multiply by 6. 5/12 already has a denominator of 12, so it stays the same. Then 8/3 becomes 32/12 when we multiply by 4. And 15/4 becomes 45/12 after multiplying by 3. Part 2 now asks us to order the fractions from greatest to least. We look at the numerators to do that. 45 is the greatest, then 32, 6, and 5 is the smallest. But remember, to get a final answer to a question like this, we have to rewrite those in their original forms. So, the final answer to part 2 is 3 3/4, 8/3, 1/2, and 10/24, the correct order written in their original forms. Oh, right! The 2 questions at the end. Why is using a common denominator helpful when comparing fractions? Well, when we have a common denominator, it means our pieces are all the same size, and we can use the numerators to compare the number of pieces. And what might happen if we tried to compare the original fractions without one? Without a common denominator, it's hard to tell exactly how each fraction compares to the other because the denominators represent different sized parts of a whole. Rewriting them with a common denominator lets us compare the same sized parts of a whole. So, what have we learned today? We learned that comparing and ordering fractions is only possible once they have a common denominator, that converting mixed numbers and improper fractions to one form makes it easier to compare, and that recording your final answer in the fraction's original form helps you know which fraction is which. You've earned the Comparing and Ordering Fractions badge, but your training isn't over just yet. Be sure to complete the practice questions and extension activities that go with this lesson to practice ordering fractions. And remember, Math Masters, in math, as in training, progress comes with patience and practice. I'll see you next time.
Hey, hey.